Nowadays, the amount of data being generated is enormous. Most companies are now analyzing their data to discover trends and patterns that can help them grow their business, go after new markets, build new products. So, if you want to analyze and understand your data, you need to use tools to help you create data visualizations. The best programming language to do this is, of course, Python. Python has a very rich, powerful data science ecosystem with many libraries that can help you create smart and advanced visualizations that are compelling and influential and also ready for publication. So my name is Biswa. I'm a Python developer and a cybersecurity engineer. I have also been an instructor and a blogger for a while now. Welcome to my YouTube channel, Code with Ultimate Passion. In this video series, I will show you how to build compelling data visualizations using Python programming language. I will also give you an overview of the tools available. Then I will show you how to manipulate data using pandas, NumPy, libraries, and how to take data and create visualizations using Matplotlib, C1 libraries. I will also show you how to create box plots, histograms, heat maps, and many more cool stuffs. Before we proceed with the course, so there are some prerequisites I must mention. So you should be familiar with the data structure of Python like set, list, dictionaries, and arrays in Python programming language. You should also be familiar with basics of Matplotlib, Cbon, and NumPy and pandas. So let's go get on with it. On my screen, if you can see, I have a bar plot which has been built using a Matplotlib library and NumPy library. So before proceeding with this series, sequentially, let's get on with it and see how did I develop this particular bar graph over here. So first of all, I am using Jupyter notebooks. You could also use other, you know, Python interpreters like PyCharm or Visual Studio. I am using Jupyter notebooks here because it is easy to visualize graphs and plots in Jupyter notebook than in any other Python interpreters. So let's get started with it. So first I am importing the NumPy library. If you so let me brief about NumPy. So NumPy stands for numerical Python as a library for the Python programming language. It's adding support for large multidimensional arrays, matrices, along with a large collection of high-level mathematical functions to operate on these arrays. So we will be using NumPy to create a three-dimensional matrix or array over here. Okay, so next we are writing Matplotlib inline. We are setting the Matplotlib library to run inline. So we are also importing matplotlib.pyplot as PLT. PLT here is used as an alias. So let's get to know Matplotlib a little better. Matplotlib is a plotting library for the Python programming language. It's numerical mathematics extension NumPy. It provides an object-oriented API for embedding plots into applications using general-purpose GUI toolkits like Tkinter, WXPython, Qt, and GTK+. It's truly friendly, is very friendly, and is very powerful in in plotting advanced um, uh, plots for data visualizations, or you could say graphs. Is very friendly and very advanced for data visualizations, you could say. So first I am creating a data structure, a three-dimensional array. So this is how you create a three-dimensional array. This is one of the ways you create a three-dimensional array using NumPy. So you have you this is you I have given if I show you like this, you would probably understand it better. Okay, so inside the braces I have three list, and this creates a three-dimensional array. Yeah. So next, what I have done is I have created a variable which is set to numpy np.arrange, and I'm passing 4 as a parameter. So let's talk about numpy arrange. Numpy arrange is one of the array creation routines based on numerical ranges. It creates an instance of nd array with evenly spaced values and returns the reference to it. So I can pass here three values. One is start, then stop, then step. Okay, so and it will evenly produce numbers between start and stop, and the numbers will be having a difference of step in between them. So when I write numpy.np.arrange 4, I have not used start and step. Start is 0 by default and stop is 1. So I will have a number, I have an array of 0 to 3. The figure, I am plotting figured this particular figure using plt.figure function. The figure function in pyplot module of matplotlib library is used to create a new figure. Then I am creating a variable and setting it to figure fig.addAccess, and I'm passing a list into it. So let's see what it's about. So there are two functions in Matplotlib, add access and add subplot. These two can be used to add an access to a figure. They both return a subclass of matplotlib.access.access object. The calling signature of addAccess is addAccess with a variable passed as argument, where the variable rect is a list, and this is starting element is x0, then xy y0, width and height, denoting the lower left point of the new axis in the figure coordinates x0 y0 and its height, width and height. So the axis is positioned in absolute coordinates on the canvas. So x0 is the originating position on x-axis, y0 is the originating position on y-axis. Width is the distance along y-axis, along x-axis, and height is the distance along y-axis. So when I passed in add access and passed in a list of 0011, I am mentioning I want to originate my plot at the origin 00 x and y axis, and the height should be 1 and width should be 1. Next, let's go on and plot the graph. The Matplotlib API in Python provides the bar function, which can be used in MATLAB style use or as an object-oriented API. The syntax of the bar function to be used with the access is as follows. So when you have plt object dot it has a method dot bar. You are accessing the method and you are passing the following arguments. First one is x, the x-axis is going to be a list or an array. Height is also going to be a list and array or an array. The width, bottom, alignment, and there are other factors or parameters that you can pass, color, bg color. There are a few more which we will talk about in future videos. So I'm passing here for the first bar graph, I'm passing here x dot 0 dot 0 0. If you know, x is np dot arrange, and we passed in parameter 4 as an argument, so it produces an array with elements 0 1 2 3. So when I'm saying x plus 0 dot 0, it says this refers to the array 0 1 2 3. But 0.000, 0.00, 1.00, 2.00, 3.00, it converts the integer array into floating point array. Then I'm passing the height again, so the dimension of x and dimension of height should be same. So as an x, I'm passing an array of 4 elements, So as in height, I should pass an array or a list of 4 elements. So sample 3D data, if you see here, so I'm referring to the first element by accessing its 0th index. So it's actually referring to this particular list: 30, 25, 50, and 20. So again, so here in my x-axis, I am passing an array which is equal to the elements 0.00, 1.00, 2.00, 3.00, an array having 4 elements, and I'm passing y or height, which also has 4 elements in it, which is a list containing elements 30, 25, 50, and 20. So the size of these two arrays or list are same. That's what you need to do when you are plotting a bar. If the sizes are different, it is going to throw an error. It is going to throw an error. Okay, so I'm defining a color for B for blue. So this the first bar will be having the color B. The width is the width of the bar you are specifying. It is applicable to for the all the bars that is being produced here. Okay, and next one the same. I'm changing the position of x from 0 to 0.25. So my uh, the x-axis becomes 0, 0.25, 1.25, 2.25, and 3.25. This is referred. The first one is referring to the blue bar. If you see the x dot bar, the first line. Okay, if I remove this and plot this, you will see the first line, the first bar command or code did the following. It plotted bar graph. Okay, the first one started with 0.0, then 1.0, 2.0, 3.0 with color blue, and corresponding heights are 30, then 25, 50, then 20. Yeah. Then I am going to uncomment out the second one. I'm going to run it again. Now you see I'm going to uncomment out first one, comment out first one, run it again. Now you see x plus 0.25. So x is 0, 1, 2, 3. X plus 0.25 becomes an array of elements 0.25, 1.25, 2.25, 3.25. And that is the exact place where the bar plots have been plotted in this particular graph. And with heights equal to sample 3D data index with index 1. That refers to this particular list: 40, 23, 51, and 17. Again, the size of the x-axis and size of the y-axis is same. That's why you have been able to plot it. Color is green and width is 0.25. Okay, now I'm going to uncomment out this one and uncomment out the last bar. And again, I'm going to run it. Now see, the x is 0.50, x plus 0.50. So x is 0, 1, 2, 3. X plus 0.50 becomes 0.5, 1.5, 2.5, 3.5. And that is the exact positions that has been allocated to plot these bars in this particular graph. Height is again similar to the second index of sample 3D data, that is 35, 22, 45, 19, a list containing these elements 35, 22, 45, 19. Again, the sizes of both x and y axis elements are same. Color is red, width is 0.25. I hope you have understood the concept behind plotting these bars. I'm going to uncomment out all these things and run it again. So now you see all of them have been plotted together in the graph, and how cool does this look, doesn't it? So once again, to revise, we imported NumPy, we imported Matplotlib as .pyplot as PLT. We created a sample 3D data using three-dimensional array. We created x-axis as baseline x-axis array, nd array, that is 0 1 2 3, by using the command np.arrange, passing 4 as parameter as argument into it. We created a figure with plt.figure. We added access with fig.addAccess, and we passed on a list with 0011 elements as an arguments inside it, which actually set the originating position or the origin to 00, and set the height to 1 and width to 1. Then we started plotting the bar charts. So I hope this is clear. So this is all we are going to discuss for the first video, and from the next video onwards, we will start it sequentially. We will first go on learning about NumPy, then we will get on learning about pandas, then we will come to Matplotlib. We will work with real-time views, data structures or data. We will structure the data. We will enrich the data with useful